As the notes tell you here, the chain rule is one of the biggest things you can learn in calculus. You're going to use it over and over and over again. It lets you do things that you just can't do otherwise. Look at some of the things that we've been doing without the chain rule. For example, this one right here. Easy, right? It's just going to be the derivative of y is going to be 2x. Well, what happens though when you put it inside a radical? That changes things. Look at something as simple as this. We know that the derivative of y here is going to be what? Cosine x. Done deal. But what happens when we put something like this inside the sine function? We haven't seen any problems like that up to now. Look at just this. What's the derivative? 3. What happens when we put that same thing inside of a power? We haven't seen anything like that yet. So get ready to learn something that's really going to help your calculus take a big leap. Down here I highlighted, look what this is saying. You can take the derivative of y with respect to x. Okay, that's what we've been doing. By taking the derivative of y with respect to a third variable and then multiplying it by the derivative of the, wow. Clear as mud, right? Let's talk about what that really means. Okay, here's the actual chain rule. And notice I highlighted the bottom part of it here and then added a little bit to the notes. Really, all this is saying is take the derivative of the outside part, that'll make more sense in a minute, and multiply it by the derivative of the inside part. So all this is really is saying we're working our way from the outside in. Now when we've got parentheses in math, what do we usually do? We work our way from the inside out. This is a completely different thought. We're looking at the big picture first and then zooming in. Looking at this first example, it's really no different from some things we've seen. What's different here is just the way we're going to visualize this. So as we're working this thing, zoomed all the way out, I've got something, this something right here, that the book and the notes are going to call u. We're just saying, okay, let's substitute here. Let's let u equal x plus 1. This is actually using the rule that you just saw. Now then, what have I got here? I've got f of u, okay, go ahead and laugh, and equals the negative 1 power. So then f prime of u equals what? Negative 1 times u to the negative 2. Well, if this is u up here, what's the derivative of u? Isn't it just 1? I'm looking at the derivative of x plus 1. It's just 1. So I've got to put du out here because we're not talking about x right now, we're talking about u. Now I can go back and translate this. So then f prime of x, let's resubstitute here. I've got negative, well, what was u? This thing, to the negative 2 times du, which is 1. So it equals negative x plus 1 to the negative 2 power times 1. Well, we could rewrite that as this. And you might be going, yeah, Ladley, I could have already done that. And you're right, but why could you have already done it? Because this inside part here had a derivative of 1. What happens when that's not the case? What happens when the inside part, if you will, does not have a derivative of 1? That's where the chain rule starts getting important. For instance, let's take a look at this second one. Now I've got the sign of 2x. Before, we've worked on the sign of just x. I can say, all right, what's the inside part here? Well, it's at 2x. I'm going to let u equal 2x. Well, what's the derivative of u? 2. So if I've got my function as a function of u, it equals what? Sine of u. So then f prime of that function equals cosine of u du. Don't forget the du, because it's the derivative with respect to u. Don't forget. Let's go back and substitute back. So I've got sine, well, what's u? It's 2x. Sine of 2x. What's du? 2. I can rewrite that then as 2 times the sine of 2x. Couldn't do that before. Okay, so let me remind you what we just did. We zoomed out and just looked at this as we're taking the sine of something. That's the big picture. That's the outside function, if you will. We computed our derivative with respect to that zoomed out version. We're starting at the outside, looking in. So once we got that, then we said, all right, what is the derivative of the inside part? In this case, the 2x. We found it was 2, and then we applied the chain rule. Let's look at a couple more. First one here. Just look at it for a second. I've got a function inside a function, if you will. I've got an inner part and an outer part. Well, what's the inner part here? I would say the inner part is this 3x squared minus x minus 1. Well, that's what we're going to call u. Then what's the derivative of u? Well, I just take the derivative of this thing. So I've got, just like we normally would, 6x minus 1. Now let's work the problem. So I've got f of u equals something that we're taking the square root of. So I've got u to the 1/2 power. See, I'm zoomed out. The derivative of that with respect to u is our old pal 1/2 u to the negative 1/2 power du. Okay, what is that in terms of x now? Oh, we could go ahead and work this out a little bit further. We could say this is really, well, something to the 1/2 power is like this, right? The negative 1/2 power is something like that, times that 1/2. So I'd really have 1/2 square root of u. Yeah? Let's go back and substitute now. So f prime of x equals 1/2. Now u, remember, is 3x squared minus x minus 1. So I've got the square root of 3x squared minus x minus 1. All of that is under 1, but I can't forget the derivative of this inside part. The inside part is u. So I've got to say, all right, that's multiplied times 6x minus 1. Look what we just did. The outside part is just this. The inside part is our 3x squared minus x minus 1. So we found the derivative of the outside part, and then we had to multiply it times the derivative of the inside part. We're starting at the outside, working our way in. So this is going to equal what? Well, 6x minus 1 over 2 times the square root of 3x squared minus x minus 1. Imagine trying to do that without the chain rule. I think you're going to discover that some of the ones that really tax your mentality and sanity are the ones involving trig functions. So I'm looking at this example D and seeing tangent squared of x. What does that really mean? Let's rewrite it. That means tangent of x squared. That's really what that means. You might have forgotten. All right, so what's the inside part here? Well, the tan x. So I'm going to let u equal tangent of x. What's du? Well, if I just given you this problem, oh, f of x equals tan x, you wouldn't have any problem going, all right, well, the derivative of that is going to be secant squared x. All right, so let's put this into motion here. So I've got f of u equals what? Think about what u is standing for, tan x. So I've got u squared, don't I? Then this becomes just a power rule kind of thing, but it's a general power rule that we're incorporating the chain rule into. Okay, so I've got f prime of u equals 2u, and then to the 1 power, so just 2u du. So then I go back and put my x in. F prime of x equals 2 times u, so it would be 2 times tan x, and then the derivative of u, which is secant squared x, and that's it. So let's take a look at what the general power rule looks like. All right, here's the general power rule. Just take a look at it for a second. It's taking that special power rule that we looked at before when we weren't considering the chain rule and just modifies it so that now it incorporates the chain rule. How does it do that? Well, it's including this derivative of u in here. And please pay attention to the last couple of sentences on this page. It can be extended to multiple interior functions. What does that mean? That means so far we've considered an outside function and an inside function. But what if that inside function contained a function? We can keep drilling down further and further and further with this rule. Really, really powerful. Let's take a look. All right, we've got 3x minus 2x cubed to the 4th power. What's our inside part here? 3x minus 2x cubed. Let's let that be u. And you don't have to keep writing the u over and over and over again, but just right at the start I think it might help you. Well, what's the derivative of u? 3 minus 6x squared. So let's see where this leads us. I've got function of u equals, now we're taking something to the 4th power. Well, that something is our u. The derivative of that would be 4u to the 3rd power du. Alright, we put our x back in. That's f prime, by the way. Put our x back in and we get what? 4 times 3x minus 2x cubed to the third power times the derivative with respect to u, but now we're changing it to with respect to x, so this is 3 minus 6x squared. Now we're not going to multiply all this stuff out, but we could simplify it some. You ought to be thinking in terms of simplification, so I'm going to say, well, 4 times this thing out here would give me what? 12 minus 24x squared times 3x minus 2x cubed to the third power. And we could sure leave it at that. There's no point in multiplying all that stuff out. There just isn't. Here comes another trig one. Again, watch out for these. So the inside part here, let's rewrite this so you can get a picture of what's going on. Sine of 4x to the 7th. That's really what's going on here. So the inside part here is sine of 4x. Alright, so the derivative of that is what? Cosine of 4x. Piece of cake. So I've got f of u equals u to the 7th. So the derivative of that would be 7u to the 6th du. We put our x back in, so I've got f prime of x equals what? 7 times sine of 4x, right, to the 6th, times its derivative now, du, is going to be cosine 4x. Watch out. Look at cosine of 4x. There's an inner part to that. What's the inner part to that? Well, 4x. It's not cosine of x, it's cosine of 4x. So I've got to take the derivative of this 4x, which is just 4. Watch out for these. So let's put all this stuff together. So I've got 28 sine 4x to the 6th times cosine of 4x. That time we chained the rule along several times. That 4x let us drill down even further. But notice what we did. We just took the derivative of it. That's the chain rule in action. First up is a product rule. I've got two functions here. How do we get the derivative using the product rule? We take the first function times the derivative of the second plus the second function times the derivative of the first. So let's map out our functions here. The simplest one is this one. This one a little more complex. So let's concentrate on getting the derivative of that second one. I've got 1 minus x squared to the 1/2 power. That's that function. What's its derivative? I'm leaving the u notation out because I think it would muddy the waters on this one. The derivative of this thing would be 1/2 1 minus x squared to the negative 1/2 times, we got an inside part here. The derivative of the 1 minus x squared would just be minus 2x, wouldn't it? Okay, if that's good, then I can take this and multiply it times this 1/2. When I do that, I get negative 2x over 2. My 2's will cancel, which just leaves me negative x. Now that's times the rest of this here. So that's going to be times 1 minus x squared to the negative 1/2. That's the derivative of the second function. So I just shrank that down some so it'd be out of the way. That's the derivative of our second function right here. So let's use the product rule. So I'm going to say f prime of x equals x squared, our first function, times the derivative of our second function, which we said was minus x times 1 minus x squared to the negative 1/2. Totally nasty looking. Plus our second function, which is 1 minus x squared to the 1/2 times the derivative of the first, which is just 2x. Which equals negative x cubed times this thing plus this thing didn't change any. Okay, before we jump in and start trying to multiply and figure out what these fractional exponents mean, let's pause and realize this and this are the same thing, which would mean maybe we can factor something out. Okay, this part's going to get a little strange. I want to factor out the smallest of those two things. It's similar to if I had x squared plus x to the third. How would I factor something out of that? Well, I'd pull out the smaller of those and just say this is 1 plus x, right? Nothing magic there, so we're going to do something similar. It's just going to look weird. So what I want to factor out is the smaller of the two things I've got underlined. Well, one's to the negative 1/2 power, this one, and one's to the positive 1/2 power. Which is smaller? Well, the one to the negative 1/2 power. So I want to factor out 1 minus x squared to the negative 1/2 power. So let's do that. I'm going to keep it in red. So I've got 1 minus x squared to the negative 1/2 power. What does that leave me? Well, for my first set of numbers here, I've still got my negative x cubed, but it's times what? Well, this thing that I just pulled out. So that's times 1, right? Because I just factored that out. Plus, here's where it gets a little more strange. If I take a negative 1/2 power out, I have to ask myself, what would I be leaving behind that I would be multiplying that 1 minus x squared to the negative 1/2 in order to get to the positive 1/2 power? I'm going to write it out here and let you think about this for a minute. I've still got my 2x. This would just be to the 1 power. Think about that for a minute. Here's a simplified idea of it. If I've got a to the minus 1/2 times a to the first, what do I do with those exponents? I add them because the bases are the same. So negative 1/2 plus 1 equals a to the 1/2. Well, that's what I did right here. It's exactly the same thing. It just looks strange because of that inner part. So if I took that 1 minus x squared to the negative 1/2 in red and multiplied it times the 1 minus x squared to the 1 power, I would get 1 minus x squared to the 1/2 power, which is what I started with back up here. Okay. I'm going to leave this in red out here. So I've got 1 minus x squared to the negative 1/2 power. What does that leave me on the inside? I'll write it in blue. I've got negative x cubed plus, when I multiply this 2x times 1, I get 2x. When I multiply the 2x times negative x squared, I get negative 2x cubed. It's getting simpler. It's getting simpler. If I combine terms here, I've got 1 minus x squared, still in red, just to let you know where it came from, times negative x cubed, negative 2x cubed is negative 3x cubed. Those cancel. Plus 2x. We're almost there, y'all. Now then, look at this. I'm going to simplify. I do not want to leave a negative fractional exponent, but what does that mean? That means the negative 1/2 power just means put it on the bottom, right? So this would really be 1 minus x squared to the positive 1/2 if I took this and put it down here. And so if I wanted to, let me shrink that just a second. So I could rewrite this then as negative 3x cubed plus 2x. Well, 1 minus x squared to the 1/2 power is just the square root of 1 minus x squared. And that would be the derivative of that function we started with. Who said this can't be fun? As if things couldn't get worse. That was the product rule. Let's do a quotient rule 1. Alright, so let's rewrite this as x over, oh man, I've got the cube root of something here, so I've got x squared plus 4 to the 1/3 power. How's the quotient rule work? It says take this bottom thing, bring it up, so I've got x squared plus 4 to the 1/3 times, this is f prime by the way, times the derivative of my top value. Well, derivative of x is just 1. Okay. Minus x times the derivative of the second. That's where we hit a bit of a wall. Let's take a look at what we got going on here. So the derivative of this thing Sorry. So the derivative of this thing, let's pull it out and look at it here. X squared plus 4 to the 1/3. Its derivative would be 1/3 x squared plus 4 to the negative 2/3 times the derivative of the inside part, which is just 2x. Alright, I'm seeing this 2x times 1/3 would give me 2/3 x times x squared plus 4 to the negative 2/3 power. There's my derivative of that lower function, the denominator function. So that's what I've got to put in here. I've got x times 2x over 3 times x squared plus 4 to the negative 2/3. All of that is over our denominator squared, so that's going to be x squared plus 4 to the 1/3 squared. Okay, I copied this over to a new page because we were sure going to run out of room on this one. So let's clean this up just a little bit. So I've got x squared plus 4 to the 1/3 minus negative x times 2x is going to be minus 2x squared over 3 times x squared plus 4 to the negative 2/3. Again, don't just jump in and start trying to multiply. I'm looking at this, and they are the same. So let's use our factor trick from the previous problem. I'm looking at the first one here. It's to the positive 1/3. The second one is to the negative 2/3. So what am I going to factor out? Yeah, right, the one with the negative 2/3. So I say x squared plus 4 to the negative 2/3. What does that leave me? The first one here is to the positive 1/3 power. What would that have to be so that if I added negative 2/3 to it, I would get positive 1/3? Well, from that last problem we saw, that's probably going to be x squared plus 4 to the 1. If I multiplied the two things that are showing right here together, wouldn't I get, in blue, x squared plus 4 to the 1/3 power? Okay, if you're with me. And then I've got negative 2x squared over 3 times what? Well, look, that's the very thing we factored out. So it would just be times 1. Now on the bottom, we can't forget the bottom. What's x squared plus 4 to the 1/3 squared? You know, let's think about that. If I had a to the 2nd power, better example, a to the 3rd power, and I square it, what do I get? I multiply the outside exponent times the inside exponent and get a to the 6th, right? Let's do something similar on the bottom here. So it's going to give me 2 times 1/3. So I've got x squared plus 4 to the 2/3 power equals x squared plus 4 to the negative 2/3 times, what have we got on the inside here? We've got x squared plus 4 minus 2x squared over 3. All that's over x squared plus 4 to the 2/3. Similar to what we did last time, if I take this negative exponent and bring it to the bottom, wouldn't that give me x squared plus 4 to the positive 2/3? So on top that would leave me x squared plus 4 minus 2x squared over 3. On the bottom I would have, if I multiply these two things together, the base is the same, x squared plus 4. I just add exponents. So 2/3 and 2/3 is 4/3. That's not a bad answer, but if I wanted to simplify it even more, I could say, well, let's put everything on top over denominator 3. What would that give me? Well, each of these is over 1, so my common denominator is 3. So I would have 3x squared plus 3 times the 4 that was there minus, well, 2x squared is already over 3. All that's over x squared plus 4 to the 4/3. So I start combining like terms, and I got 3x squared minus 2x squared is going to be x squared plus 12 over 3 over this. Lastly, if I did a keep change flip kind of thing, this 3 would come down here, which means I'd have x squared plus 12 over 3 times x squared plus 4 to the 4/3. Here's another fun one. This time we're combining a power rule, quotient rule, and the chain rule. So to get f prime of x, what are we going to do? First of all, visualize this whole thing as just u, and that u is being raised to the 2nd power. I just bring the 2 out front, and on the inside I would leave all the inside stuff. Alright, then I have to get the derivative of that inside part. That's where the quotient rule comes in. So the quotient rule says I'm just getting the derivative of this part now. the derivative of that would be the bottom times the derivative of the top, which is just 3, minus the top times the derivative of the bottom, which is just 2x. All that's over x squared plus 3 squared. And again, in black, I'm just working on the derivative of u, as it were. So then I've got x squared times 3, so 3x squared, plus 9, minus 3x times 2x, so minus 6x squared, and then minus 1, actually it's a minus 1 times 2x, so it's plus 2x. All of that's over this. And so I've got 3x squared minus 6x squared, so that's minus 3x squared, plus 2x, plus 9, over x squared plus 3 to the second power. But remember, that's just the derivative part of our u, so that's du, if you will. So let's go back. I've got my original thing here. Times the derivative part which is going to equal what now? So I've got 3x times minus 3x squared, so negative 9x cubed, then 3x times 2x plus 6x squared, then 3x times 9, and then the negative 1 times each of those. So negative 1 times negative 3x squared is 3x squared. Negative 1 times 2x is negative 2x. Negative 1 times 9, negative 9. All that's over. Now look, when I multiply x squared plus 3 times x squared plus 3 squared, I'm just going to get x squared plus 3 to the third. So let's combine like terms. I've got only one x cubed, so I've got minus 9x cubed. How many squares? 6x squared, 3x squared. Nine x minus 2x, so that's 7x minus 9. All of that's over x squared plus 3 to the third. Did you catch the mistake I just made? I didn't until I got to this point right here. I forgot all about that 2 sitting out front. That 2 is going to multiply times all of this. Boy, that's an easy mistake to make. So I've got negative 18 x cubed plus 18x squared plus 14x minus 18. All that's over x squared plus 3 cubed. And now, unless I overlook something else, I think I'm done right here. Let's take a vote. Who wants to multiply that denominator out just to see if something might cancel? Yeah, I didn't think so.